Hi everybody. Yesterday we started solving quadratic equations with the square root method, and yesterday we started very basic. For instance, something like x squared equals 49, and when we see the squared on one side, x squared on one side, and a perfect square on the other, when we take the square root, we get x equals not just 7, positive n negative 7, right? And then we also took it one step further where what if there's not a radical on the other side? So, for instance, if I showed you something like, I lost it, x squared equals, let me think of a non-perfect square, let's just say 28, okay? And when, actually, you know what I want to do instead of 28? Let's just say 8, okay? And when I take the square root of both sides, x equals, you can't just leave it positive and negative radical 8, because radical 8 can be broken down. Name two numbers that multiply to radical 8, 4, and 2. 4 is a perfect square. So x equals plus or minus. The radical 4 is a perfect square. It comes out of the radical. And then we bring down rad 2. Okay? So those were pretty much the two situations that you saw yesterday and the day before. So in this last lesson, we learned to just isolate the squared term. Well, today, the squared term doesn't have to just be an x. In other words, here in this first example, that whole parenthesis, x plus 2, is being squared. So watch what I'm going to do. I'm going to still, immediately, I could take the square root of both sides because I have a squared term on one side and my number on the other. So when I do that, I get the square root of x plus 2 squared. Well, think about it. X plus 2 times itself, x plus 2, would just leave me with an x plus 2. So when you take the square root of that binomial term, it's just one of them, x plus 2. And that equals, remember, when you take the square root, you're going to get two roots, both the positive and the negative root. Now, can you break down radical 12? Are there two numbers that multiply to 12 where one of them is a perfect square? Yes, 4 and 3. So I get x plus 2 equals plus or minus. Remember, notice I put the perfect square first. This is your perfect square, and it's going to come out of the radical. What's the square root of 4? 2. Radical 3 can't be broken down any further. Now, you can't leave your answer like this because we don't have x equals. We want x by itself. So what's the inverse of that x plus 2? Minus 2 to both sides. So here's a tough concept. X is going to equal. Now, you cannot combine the negative 2 with this 2 here. These are not like terms. That 2 radical 3 is attached. So you're going to bring that negative 2 that you just brought to that side first, and then plus or minus, your 2 radical 3 comes down. So that is your answer. X equals negative 2 plus and minus 2 radical 3. If you were going to look at it in a solution set, you could say negative 2 plus 2 rad 3. That's one answer. And negative 2 minus 2 rad 3. That's your other answer. These are just irrational roots. It means that your graph, your parabola, because it's quadratic, highest exponent is 2, you're looking at a parabola. And it's going to mean that that parabola crosses your x-axis, not at beautiful rational roots. It's going to cross at irrational numbers. Okay, let's try another one. So again, your square term, is actually by itself on one side. So let me change my color. I'm going to go blue. But if you see here, you have that one term. So I'm going to take the square root of both sides. So again, picture this. X minus 3 squared. is x minus 3 times itself. So the square root of that is just one of the x minus 3's, okay, without the squared anymore. Now on this side, I'm going to have plus and minus. Now I'm going to break down radical 80. Let's name two numbers that multiply to 80 where one of them is a perfect square. So I'm thinking 16 and 5, right? If I do 16 times 5, I get 80. Now why am I thinking 16? It's a perfect square, and it's the biggest perfect square that's going to go into it. I know that because that radical 5 can't be broken down any further. So now watch, I'm going to take that radical 16, it's a perfect square. Square root of 16 is 4. Notice there's no more radical. Kids will want to break that down again. You're done. The square root of 16 is 4. And now, what's your inverse operation? Here, you're going to add this 3 to the other side. But once again, this 3 cannot be combined with 4 radical 5. It goes in front. 3 plus or minus 4 radical 5. Okay, you could show your answer like that. You could show 3 plus or minus 4 rad 5. That's a really nice way to show it. That's still showing two different solutions. 3 plus 4 rad 5, 3 minus 4 rad 5. Okay. Okay, I'm going to move on to the next one. Now in number 3, very different. You no longer only have this base of x plus 1 to the second power. You have that 2 in front. You have to get rid of that 2. So what are you going to do? That's multiplication. Divide both sides by 2. So that's going to give us x plus 1 squared equals 54 divided by 2 is 27. And now I am going to take the square root of both sides. So when I take the square root of this side, I get my x plus 1, no more squared. And here, I'm going to break down 27, because there is a perfect square that goes into 27. 9 and 3, which means that becomes x plus 1 equals plus or minus 3 rad 3. And if I do my inverse operation here, which is minusing 1 from both sides, I get my answer to be negative 1 plus or minus 3 rad 3. That whole thing, negative 1 plus 3 rad 3, and negative 1 minus 3 rad 3. There's two answers there, okay? You could show it how I showed number 1 and number 3, or you could show your solution how I showed number 2. It doesn't matter. Okay, so let's try a few more. These aren't easy. Let's do this. Okay, so for example, like number 4, think about a similar equation that looks much easier to solve. So once again, you want to get this, your base and your exponent by itself. So what are we going to undo first? Always undo addition or subtraction. Just like we see to the right. What would I do first here in the similar equation? I bet you all know I would add 1, right? I would add 1 and I would say, okay, 3x squared equals 135. So let's do the same thing here. Add 1 to both sides. So 3 times x minus 5 squared equals 135. And just like we did before, here I would divide both sides by 3. Okay, so I would do 135 divided by 3 and get 45. Here, I'm going to do the same thing. Get rid of this 3, and I would have x minus 5 squared equals 45. Now, just like you would on the right-hand side, take the square root of both sides. Here we're going to take the square root of both sides. Okay, here is similar to what we were doing yesterday, x equals plus or minus. We would break down into 9 and 5, and I would get an answer of plus or minus 3 rad 5. Here, it's going to be one step further. X minus 5 equals plus or minus 9 and 5. We're at 9 and 5. So x minus 5 equals plus or minus 3 rad 5. Well, what's the one extra little step? You have to move that 5 over. So here, x equals 5 plus or minus 3 rad 5. So your solutions are 5 plus 3 rad 5 and minus 3 rad 5. So I'm going to write it in as one thing. Here, your solutions were only plus and minus 3 rad 5. So what was the big difference? You just have that extra number in the front. 5 plus or minus 3 rad 5 as opposed to 3 plus or minus rad 5. Okay, let's give you another one. In number 5, you actually have the radical isolated. I shouldn't say the radical isolated, excuse me. The base isolated to a power of 2. So when I take the square root of both sides, I get x plus 6 equals plus or minus, well, I'm not going to break this down. Why not? Because I'm praying you're all going to immediately say that's a perfect square. And a perfect square doesn't get broken down. It just comes right out of the radical. What's the square root of 81? 9. Now, not only is it positive 9, it's also negative 9. So in this next step, I would, let me get a new color, subtract 6 from both sides. So now here's what's tough. Technically, it's x equals 9 minus 6 and x equals negative 9 minus 6. There's two 9s here, a positive and a negative. See that? So you could do that. What's 9 minus 6? 3. What's negative 9 minus 6? Negative 15. So here there are two answers, 3 and negative 15. So what's so different about that last question? If there's no more radical and it's not like a 5 plus or minus 3 rad 5, it means we can express our answers as, you want to write, these are rational solutions. They can be expressed as fractions. Okay, you could say 3 over 1, negative 15 over 1. Rational means fractional. So there's no more irrational, non-terminating, non-repeating decimals, okay? So it just means that it was factorable. So I'm giving you that exact same question. Okay, so what does that mean and what does that look like? Well, you could have factored it. So how could I have factored this? Well, watch this. If you see and you want to solve this equation, x plus 6 squared, right? So hopefully a lot of you are thinking, okay, x plus 6 times itself, x plus 6 equals 81, right? And you could either set up a box or do a double distribute and get x squared plus 6x plus 6x plus 36, which equals 81. Okay, these are like terms, and it makes sense. X squared plus 12x plus 36 equals 81. But this, obviously, is quadratic. And if it's quadratic, it means it should look like this. Ax squared plus bx plus c equals 0. We're looking at potentially a trinomial. So I'm going to take that 81 and move it to the other side. Okay? And I'm going to say, what's 36 minus 81? Negative 45. Okay. So now this is back to what we were doing a week ago. This is a basic trinomial. We are going to factor it. What two numbers multiply to negative 45 and add to positive 12? It's got to be a 15 and a 3, but one of them has to be negative. I'm going to make the 3 negative because the 12 has to be positive, which means it's got to be a positive 15 and then a minus 3. So I have an x plus 15 I have an x minus 3, and it equals 0. But remember, if you want solutions, I'm going to take those factors, set them equal to 0, do the inverse, and x equals negative 15. Do the inverse on this side and get x equals 3. And look at my solutions, 3 and negative 15. Take note, 3 and negative 15. They are the exact same solutions here because it's the exact same question, x plus 6 squared equals 81, that I was able to do in two different ways. You could either factor it or you could solve by square roots. Now here's the thing. The reason I knew, okay, once I did it using square roots, that I could factor it was because I got numbers, rational numbers, like a 3 and a negative 15, as opposed to 5 plus or minus 3 rad 5, or negative 1 plus or minus 3 rad 3. Those are irrational solutions, which means they are not factorable. Okay, so I'm going to stop there. I'm going to let you guys try a couple on your own, and you let me know if you need help.